Here is a question from previous test paper. We need to sketch the function f of x equals to 2 cos x minus sin 2x in the interval minus pi to plus pi. Now, for such functions, what we can do is, first let's find these values at the boundary conditions, right? So f of minus pi is equal to, let's substitute, we get 2 cos of minus pi minus sine 2 pi, right? Minus, let me write minus here. So, you know sine and cosine functions, which are kind of like this. Let me sketch the sine function first. Sine function is kind of like this. Within minus pi by 2, this is minus pi and this is plus pi for sine function. And for cosine function, it is going to be like this, right? Which is minus pi to pi. That is for cos x. So at minus pi, sine is 0. So this part is 0, right? And cos x is minus 1. So we get minus 1 here. So what do we get here is actually minus 2. And that part is 0. Now, what is f of pi equals to? So when I substitute pi here, we get cos of pi minus sine 2 pi. Now for pi, again, cos is negative 1 and sine is 0. So we again get minus 2, right? Now, to analyze this function, let us find the x-intercepts and also the derivatives. So x-intercepts is when this function is 0. So to find x-intercepts, we'll substitute f of x is 0. So that means we get 2 cos x minus sine 2x. Now, so we could write sine 2x 2 sine x cos x. So I could write this as 2 cos x minus 2 sine x cos x, correct? So what we get here is that for fx equals to 0, we could factor out 2 cos x and we get here 1 minus sine x. That really means that we get zeros within the given interval at x equals to, when this factor is 0, that is cos x is 0. Cos x is 0 as minus pi by 2 and plus pi by 2, right? So we get plus minus pi by 2 value. And this factor is 1 at sine equals to pi by 2, which is covered, right? So pi by 2 is covered. So anyway, we got these. And let us find the value of the function when x is 0. That is the y-intercept, right? So let's find y-intercept also. That is f of 0. So now we are finding y-intercept. Y-intercept is value function at x equals to 0, which is 2 cos 0 minus sine 0. So at 0, cos is 1, and so we get this answer as 2. So the y-intercept is 2. So what we have found so far is that we have x-intercepts at this point, y-intercept at this point, and these are the values at the extreme points. Now let's try the first and second derivative. So the first derivative of the function is equal to minus 2 sine x, and here we get minus 2 cos 2x. That is the first derivative. To find the critical number, we should be in a position to equate this Now since this equation is having sine and cosine terms in it, and cos is with 2x, it's a good idea to write that cos 2x in terms of sine, correct? So we'll take minus 2 common, and we have sine x. For cos 2x, I'll replace cos 2x as, okay, let me just go one more step here. We'll write this as cos 2x for the time being, and then we will write this as sin x common. Cos 2x can be written as 1 minus 2 sine square x. 1 minus 2 sine square x. Right? So that is how we have replaced cos 2x. So I've used the formula here, that is cos 2x equals to 1 minus 2 sine square x. So now we have an equation which is a quadratic equation in sine. So let me bring down this minus. So I'm just saying 2 here now, rearranging. So we have 2 sine square x minus sine x minus 1 as my equation. Now we could factor, we are looking for product of minus 2, sum of minus 1. So this could be written as 2 sine square x, and we want minus 2 sine x plus sine x minus 1. And then we could take sine x common, 2 sine x common, and we get sine x minus 1. Here we get plus sin x minus 1, correct? Now let's go to this side to solve further. So now sin x minus 1 is common, so we get f dash x equals to 2 times sin x minus 1 common times we are left with 2 sin x plus 1. Now for critical number, we have to equate this to 0. So that gives us combinations for sin x equals to 1 or sin x equals to minus half, right? So these are the two combinations. Now sin x is 1 in the interval minus pi to pi at pi by 2, right? This is the value pi by 2. So we get x equals to pi by 2 here. And for minus half, we're looking for somewhere here. We can use the special triangle 30, 60, 90 or pi by 3, pi by 6. Now in this triangle, this is the half value for sine when we're talking about pi by 6. So minus means you are working in minus pi by 6, right? So the angle is x equals to minus pi by 6, which gives you within this interval of minus pi and pi a negative value of minus half. So there are actually two values, right? So the other value is since we are looking into quadrant, which is, see, like this. When we are looking into minus pi to plus pi, then basically, you know, the quadrant 1, 2, 3, and 4, negative value is in these two quadrants. These two quadrants, correct? So one we got negative pi by 6, and this is the other value, which is negative 5 pi by 6. So we get two solutions here, and the other one is negative 5 pi by 6. Do you see that? So these are the two critical numbers for us to find derivative for. Okay, so we have to analyze at these points. Should we have a maximum or a minimum? So we'll analyze the first derivative at these points. So we have x equals to minus pi by 6. Then we have minus 5 pi by 6. and x equals to pi by 2. So you can take a test value and then find if it is negative or positive. We are checking the derivative here, the first derivative. Correct? So the test point in these regions could be, we could take 0 here, and in minus pi by 6 and 5 pi by 6, we could take minus pi by 2 as the value. And on this side, we could take minus pi as our test point, right? On the right side of pi by 2, we could take pi as our value, correct? Okay. Now, if I substitute pi here, let's use calculator, okay, and find the answer for all these values, whether it is negative, positive, or what, correct? So the derivative is 2 times within bracket sine of, now when it is minus, then negative is negative. Do you understand? Sine of minus theta is minus sine theta, right? So I'll use minus sine theta. So I'll do minus sine theta here, right? So we get minus sine pi. And sine pi, is 0. So it doesn't really matter whether I put anything. If I put 0 sine pi here, I get minus 1 here, and I get plus 1 there, right? So that means when you multiply, you get a negative answer, correct? So we get a negative answer. So this is negative. That means that the graph of the function is down. Does it make sense? Now, if I do minus pi by 2, at minus pi by 2, sine x is minus 1. Correct? So sine x is minus 1. So this becomes negative. This is minus 1. That is positive, right? So it is positive in this position. For 0, sine x is 0. So we get minus 1 times plus 1, which is negative. And for pi, sine is 0. So we get minus 1 and this, which is again negative, right? So at this point, it is again negative. So we get kind of like this, right? So that becomes the analysis of this particular graph at the given points. It tells you that we do have a minimum here, a maximum at this point, and a point of inflection here, which you could confirm with second derivative. You get an idea, right? Now, so what we can do now here is that we can find the values at these points which are minimum. So the minimum is at x equals to minus 5 pi by 6. These are our critical points. So we have minimum at minus 5 pi by 6. And let's substitute this value in the function to calculate. Right. So when you calculate this value here, that is, what is f of minus 5 pi by 6 equal to, right? So let's substitute here. So we get 2 times cos of minus 5 pi divided by 6 minus sine two times 5 means 10, so minus 10 pi divided by 6 bracket close equal to. So in decimals we get a value which is minus 2.598, correct? So that is the value which you get for minimum. Now for maximum, which is at this point, we can say maximum is, okay, maximum value is at minus pi by 2, right? So it is at minus pi by 2. Let us substitute minus pi by 2 here and find the value of the function at minus pi by 2. So twice, I'll change this value to minus pi by 2 now, right? So we'll go back. The equation is already there. So it is minus pi by 2. And for sine, minus pi divided by 2 equals to. Okay, let me be sure, what did I write? There's divided by 6 also, something is wrong, right? It felt like. So minus pi by 2 equals to. So we get this answer as 1 minus pi by 2. We get this answer as 1, right? So, okay, we can check. So at pi by 2, cos value is 0 and the sine value is minus 1, correct? So we get minus as plus 1. That's correct. So we get a maximum value of plus 1. So from the first derivative, we could analyze that the maximum and minimum are these. And let us also check the value at the third critical point, which is where? Pi by 2, right? So let's check the value at pi by 2 also. So f of pi by 2 is equal to, which seems to be a point of inflection. So at pi by 2, cos value is 0, sine is 1, so we get minus 1 here. Right? So at pi by 2, if I substitute pi by 2 here, I get cos pi by 2 as 0 and 2 times pi by 2, I'm sorry, it is sin 2x. So sin 2 times pi by 2 is sin pi. Sin pi is also 0, so we get 0 here, sorry, this is 0. So if you substitute here, you get 0 here. Okay, so that seems to be a point of inflection for us. Anyway, we'll move on to the next page and then summarize and sketch the graph. Now let us take all this information to the next page and then sketch the graph. So what we calculated was that the function has the values at these limits. F of minus pi was minus 2, f of pi was also minus 2, and we found that the x-intercept was at, let me write here the y-intercept, that is f of 0. So if I substituted 0 here, we got the value of the function as 2, right? So if I write 0 here, I get 2, because sin 2x was 0, this is 1. Okay, so this is what we got. And we also found that maximum value occurs at the value of minus pi by 2, and the maximum was equal to, no, the maximum was at minus pi by 2 and was equal to 1, right? The minimum value of this function was at minus 5 pi by 6, and that was calculated to minus 2.598, right? And what else? And we found that the point of inflection was at pi by 2 and the value was 0, right? So I got these values. Plus we also found the x-intercepts, right? So we also found the x-intercepts. X-intercepts were at x equals 2. Let me check. F of x plus minus pi by 2. Okay, so those were the x-intercepts, plus minus pi by 2. We are talking about this particular interval, right? So just to remind you, these were the calculations which we did, from where we are picking up all these values, correct? Okay, now let me write the function here. The function f of x is equals to 2 cos x minus sine 2x. We are working in the interval minus pi to pi. And the first derivative of this function was, in the simplified form, 2 times sine x minus 1 times 2 sine x plus 1, right? So that was the first derivative. And the critical points were critical numbers. Numbers were at x equals to pi by 2, minus pi by 6, and minus 5 pi by 6. Let me write them in order. Minus pi by 6 and pi by 2. Correct? So those results are there. So these are the critical numbers which we are working with. Now let's try to sketch the function itself. Now we also analyze the derivative. So it is kind of important to see increasing and decreasing intervals. So when we analyze the first derivative, which was this equation, at these critical points, which are minus 5 pi by 6, minus pi by 6, and pi by 2, we saw that the graph is kind of decreasing here, then increasing, decreasing, and then decreasing, right? So that is the nature of the graph. So that is your decreasing interval, increasing interval, decreasing interval, decreasing interval. Correct? So putting all these things together, what we have here is, let's say this is, so we have to sketch between pi, minus and plus pi, and here we have pi by 2, okay, and the critical numbers are at 5 pi by 6. So 5 pi by 6 minus is close to pi, is kind of here, and then pi by 6 is close to this place, and then pi by 2 is here. So these are your critical numbers. The value at pi by 2 is right there, and this is kind of a point of inflection, right? It's just kind of like this. The graph is going down. The value at, let's put this y-intercept is 2 for us. So somewhere here, let's say this is 1, and let's say this is 2. So the y-intercept is 2. So this is the y-intercept 2. Now at the extreme values, we have minus 2. So let's say these points are, both are minus 2 for us, right? So this is minus 2 for us. Is it okay? And that is 2 for us. Okay. So we have placed these 3 points. Now let's look into maximum and minimum value. Maximum is at minus pi by 2. So minus pi by 2 gives you a maximum of, wrote it wrong. It is minus pi by 6. I'm sorry. The maximum value was at minus pi by 6, right? So it is, sorry, this is minus pi by 6, not pi by 2. So let me rewrite this. There is a mistake here. It was at minus pi by 6, and the value was 2.598, right? This value. So at minus pi by 6, we got 2.598. That's correct. So that is the turning point. So more than 2, let's say somewhere here, right? So that is the turning point of maximum. The minimum value is minus 5 pi by 6, somewhere here, right? So somewhere here. So this is the turning point at minimum. And the x-intercepts were, x-intercept is minus pi by 2. So that is one x-intercept. This is the other one. So that becomes your graph connecting these points. Perfect. So let us connect these points and sketch the graph of our function. So from here we can say kind of like this. We are kind of reducing ourselves to this point, going up, coming down from here, and then this is like a point of inflection here, right? And then we go like this. But that's the that is the way it goes, correct? Now, let me label these points. So here we have minus pi by 2, pi by 2, pi, correct? And this value is minus pi by 6, where we get maximum. And this is minus 5 pi by 6, where we get local minimum. And the local minimum is minus 2.598. The maximum is 2.598, correct? So that is how you can combine all the information and place it on this. So I hope that makes sense, right? Feel free to write your comments, share your views, and I hope you like it. If you like and subscribe my videos, that'd be great. Thank you, and all the best.